So let's look at interpreting graphs and real-life graphs. And we'll start with distance-time graphs. So question 1 on page 398. This travel graph gives the distances of a boy from his home, and the boy travels away from his home over time. Okay, so on this side it's distance, and it's in kilometers, and this side is time in hours. Okay, so when did he leave home? Well, it looks like he left home at 9 a.m. And when did he get home? Well, it looks like he got back home at 3 p.m. How far was he from home at 1 p.m? So we have to go up to 1 p.m. and we see that he was 30 kilometers. So we've extrapolated the data by doing up the graph. At what time was he 15 kilometers from home? So we have to go up halfway here and bring it down, and the time, sorry, I've done that a bit askew, it's about 9:45. Okay, and also actually there's another time if I go across to here at 2 p.m. as well. So it's 15 kilometers, about 9:45. That's 9, half 9, 10, 9:45, and 2 p.m. He was 15 kilometers from home. And when did he rest? Well, he rested here and here. Twice he rested. He rested at 10 o'clock to, I would say, about half 10, and from noon to 1 o'clock. And we know that he's rested because the distance hasn't increased over time, it's flat. Okay? And when was he travelling most quickly? Well, to do that we need to examine the slopes. There's 3 slopes in this graph, and the steepest slope is the quickest. Okay, sorry. Okay, the steepest slope is the quickest. So that's a slow rising distance, slow distance over a long time, and that's a very large distance over a short length of time. Okay, so anyway, we'll have a look at this. So slopes go steeper is faster. So when between 9 and 10, the rise over the run. So there's the rise. Sorry, 9 and 10. There's the rise. It's 20. Over the run is 1 hour, 20 kilometers per hour. For the next one, the rise over the run goes from half 10. Goes from half 10 to noon. That's an hour and a half. 10 kilometers in an hour and a half. So the slope, that's 6.6 kilometers per hour. And finally, the last rise over run goes from the rise of 30 kilometers over 2 hours. So 30 divided by 2 gives the slope of 15 kilometers per hour. So he was fastest between 9 and 10 when he took off out the door. So let's look at directly proportional graphs. Graphs illustrate data that's directly proportional because if they do, then they should always show a straight line through the origin. And what we mean by directly proportional to variables, we mean that, if we charge 50 cents for 1 apple and €1 for 2 apples and €1.50 for 3 apples, then the cost of apples and the number of apples is directly proportional, in that an increase in one causes an increase in the other by the same relative amount. Okay, so which of the 4 graphs here illustrate the direct proportion between h and t, the 2 made-up variables? Not this one, because it doesn't begin at 0. Not this one, because it's not directly proportional. It should be a straight line going through the origin. Not this one, because although it starts off as directly proportional, it changes, so it's not fully directly proportional. This is the graph that illustrates a direct proportion. Okay, and then we'll look at question 8, page 406. The graph shows cost of broadband for 1 month on 3 tariffs. The first one, there's a rental of €30 per month and 10 cents per gigabyte download. The next one is no rent and 30 cents per gigabyte download. And the third one, there's a rent of 37.50 plus only 5 cents per gigabyte, with the first 60 gigs free. So we have to try and match these lines A, B, and C with the tariff. So the first tariff of where the rent starts at 30 is this one here. That's the starting point at 30, and then it rises 10 cents per gigabyte. So if you could work that out, if you worked out the slope. The second tariff is A, it's this one. Okay, so it's this line going from the origin. So that's T2. There's no rent, so it starts at the origin, and it has a 30 cents per gig slope. And then the third one, T3, must be C then. Okay, where it goes straight up to 60, and then it jumps up. Okay. Carol downloads more than 140 gigs a month. Which one is best? Well, T3 is the best. C is the best for Carol because it has the least steep curve. So once you go, she's going to go past 140 anyway. But at least when she's there, the rising cost per gigabyte is this flatter than the other rises in cost per gigabyte. So the T3 is the best tariff for Carol. Okay, and here's some real life graphs here now. So when water is poured into a vessel at a steady rate, the water will rise at a steady rate. So as we pour it in a steady rate, it will rise at a steady rate. And if we were to measure H over time, then we should get a proportional graph straight line through the origin for this shape. But not all shapes are cylindrical, so we have a shape like this, and you'll note that at this point, as it's getting towards the top, towards the end of the pouring, then the rate of change of height will be proportional to time. But up until that, it will vary according to the varying width of the vessel. Okay. So example 1, so on page 407, we have 5 shapes, and we have to match the graph, the rate of flow graph, with the shape. Okay, so A is graph 5, and B is graph 2. Okay, so this is steeper because A is thinner and it'll rise faster than B, which is not as steep than A, so it takes longer to slower rate of height change. Okay, shape C is represented by graph 1, where it goes from wide to thin, and D is represented by graph 3, where it fills quickly the thin bit and then takes a long time to fill. Slower rate of height change to fill. And then finally the last one is E4, where you have 1, 2, 3, 1, 2, 3 different flow rates. Flow rates leading to the change of height. Now, let's look at question 13, page 412. A stone is thrown into the air. The graph illustrates its flight. Use the graph to find height after 1.5 seconds and 7.5 seconds. This is height, this is time. So we go to 1.5 seconds and we see that it's about 60 meters. And 7.5, we go out to a time of 7.5 seconds and we see that it's about 90 meters. Okay, you'll see it in your book anyway. And then find the time for the stone to reach 80 meters on the way up. So now we go up to 80 meters, and we see that that it's about here, so it's about 2 seconds, and then we have to go across to here, and we see again it's about 8 seconds. Sorry, it's about 8 seconds. So there's 2 places on the way up and on the way down.